Thank you everyone for being here. My name is Bilal. I'm a machine learning product guy and a proud member of the Carnegie Mellon University community. So welcome to the third product management talk in our series. So today we have faculty, current students, and alumni from the Carnegie Mellon University. Some are affiliated to the CMU Silicon Valley campus and some from Pittsburgh. And I think we have engineering college students. We have also students from the Tepper Business School. We have as well practitioners from the industry, obviously, and everyone is welcome. Thank you so much for being here. We'll start with some housekeeping items. So the event is recorded, and we'll have 15-minute Q&A at the end of the session. So please feel free to ask questions. You could use the chat window to ask your questions. And your questions are welcome. Thank you for participating to this conversation. Shortly, the topic today is basically about the practice of product management for machine learning intensive products. Machine learning is everywhere, so from computer vision to voice recognition. So we choose to focus on machine learning intensive products in the marketplaces. Won't be long, just quick introduction. Marketplaces is a multi-sided product where stakeholders interact and engage. And machine learning is extensively used to optimize these interactions, the discovery of stakeholders. So in features like a recommendation engine or in search, or we'll talk about the pricing and search pricing in marketplaces like ride-sharing marketplaces. So we'll have two sections in this talk. We will first talk about the best practices of building and scaling these products. And we also going to talk in a second section about how to build a good team and also how to get into this field for new product managers. So today I'm super honored and happy to have two distinguished speakers. Faye Caldwell, who is currently the Global Director of Product and Science for Prime Video, Personalization and Discovery at Amazon, and Vishal Kapoor, who is a Director of Product Management at Shipt. Quick, bios, but I'm also happy to let you guys introduce yourselves. So Faye is also a board member of the Strauss Institute. She was before that executive vice president of product and design at Segot. And before that, she led an organization launching the online media ad platforms for video, mobile, and social monetization at Yahoo. And before that, she was with Adobe, Vodafone, Netscape, and several early stage companies. Vishal is a leader in product management who has over 20 years of experience building, launching and scaling next generation consumer products at companies such as Amazon, Microsoft, Zynga, Lyft, and most recently Shipt. So again, thank you so much for being here. Let us get directly to the core of the topic. Maybe you guys, if you'd like to add a little bit more about your background, Faye or Vishal.
Sure. So my name is Faye Caldwell. I have been in the United States for a little over 2 decades and spent my entire career in product management. Started in engineering, but my passion for building and delivering products that add value and improve everyday life has never stopped, continues to grow. And what an exciting time right now to really be part of making culture and influencing what delights people through recommendation engines for video content. So looking forward to our chat today.
Thanks for the introduction, Bilal. I'll quickly voice over as well. Actually, I also worked at Yahoo, Faye. So we missed that on, it's a small word at the end of the day. But I am director of product at Shipped currently, and my passion is working on multi-sided marketplace problems, essentially problems which have, different moving parts, and ultimately it's really one big connected machine. The complexities of working in a problem space like that, how one part affects the other, what kind of machine learning, what kind of systems can you actually build to really like build cutting edge systems to solve problems at scale for problem spaces like these, is something that I'm extremely passionate about. Very honored and very delightful to be here, and really looking forward to an inspiring conversation with everyone.
Thank you very much, guys, for being here. So we mentioned recommendation engines. I guess this is one of the oldest use cases of machine learning. And Faye, I know you've been in the industry for years now, and you've seen kind of the evolution of that particular types of product. So I'd like to hear from you about what do you think are the key ingredients to build, launch, and scale these products. What makes them successful? What's your recipe?
Thank you, Bilal, for the question. I think it's really important to give everyone a little bit of a historical perspective. To your point, recommendation systems have really been an early innovation in the AI space. The first ever recommendation engine was developed back in 1999 here in Silicon Valley at the Xerox Palo Alto Research Center. And what they've done is they built an experimental mail system. At the time it was called Tapestry. And the main purpose of this recommender was to allow people to rate documents, and then using collaborative filtering, the recommendation engine tells people what are the most loved docs that they could enjoy. So it's basically a popularity recommender. Fast forward 20 years from 92, in 2012, McKinsey & Company basically announced that Amazon drove 35% of their revenue from the recommendation engine. And they went on to do a study on how that really drove so much growth for Amazon. And it turns out it's really because Amazon recommendation engine at the time really adapted to the challenges of an increasing customer base. They kept on growing. And how do you really scale recommendations when now you're dealing with tens of millions of customers? And the way they did it is, instead of focusing on each customer separately, they created basically clustering of customers. They created cohorts of customers. And in doing so, they figured out similar choices and similar patterns of behavior. And as a result, they really saw significant improvements in the accuracy of the recommendation, ultimately revenue. So today, when you look at our world and the infinite amount of data consumers are exposed to every day, whether it's in video streaming, music streaming, books, online shopping. I mean, we live essentially online. That abundance of data and the need for ease of discovery is really what drove an increased demand for recommendation engines. And I wanted to essentially describe the job of a recommendation engine. The primary job of a recommender is to really basically advise the products, the best products for a user based on their needs and their wants. But there is a secondary job for recommenders, which is to actually filter all the data it gets from users as the user interacts with the service, whether it's a streaming service or an e-commerce site. As the user interacts with the service, the recommender engine gathers that data, filters the data, analyzes it, and then ultimately through algorithms recommends additional products. So there is a significant amount of compute that goes with that. And to bring it into perspective, it's important to know that recommendation engines have probably seen 3 generations of evolution. The first most generic recommendation engines used things like content-based or collaboration-based or hybrid type of filtering. And I'll give you an example. What is the content-based filtering? Let's say a person comes to a website and reads a news story about a particular topic, like the latest weather. And then they read an article about Prince Harry, for example. Now the engine decides that this person might be interested in the royal family. So next time they surface an article about Prince William. That's what we call content-based filtering. Based on the content consumption, you decide the filtering of the data, and you expose new recommendations to users. But there is also collaborative filtering, which is a little more interesting in the sense that a person comes to, let's say, Amazon, and they buy a tennis ball, and another person buys a tennis ball and a tennis bat. So now, because there is the affinity of buying, a bat with a ball, then that person who bought a ball, maybe they get a recommendation to buy a bat next time they visit. And that's what we call collaborative filtering. It's not based on just their behavior. It's also based on how their behavior have been augmented by other people's behavior on the service. So that's essentially, in summary, a generic way of delivering recommendations, and it's prominently used in e-commerce. The second generation of recommendation engine is what we call personalized recommender systems. These systems use social information, use demographic signals, and really attempted to try and understand users and understand their profiles and truly make the recommendation more appropriate to the person and who they are and their tastes. This is prominently used in social media. However, the latest frontier in innovation recommendation engine is what we call the deeply personalized recommenders. And these are recommenders that use a variety of signals. They use psychographics, emotional, health factors. They basically construct a knowledge base about the member to deliver deeply accurate and personal recommendations. And these are very widely used and prominent in the healthcare space, where we're seeing interesting novel use cases of specific recommendations for a better treatment for a person based on their symptoms, their specific allergies, all of their history, but also based on what's available to other users. So essentially, you can see how recommendation engines, whether generic, personalized, or deeply personalized, truly add value and change the way we consume information. So now let me come to answering your question. How do you build best of breed recommenders? It really comes down to three specific things. You really needed to deeply know your customers, deeply understand your products that you're trying to recommend to these customers. And third, you need to define a set of principles that power your recommender service. And this third one is really important because I do believe recommendation engines have a significant agency on culture. They, specifically in streaming services, they really influence what people do and not do, and the choices that people get to select from. And therefore, things like, is the recommendation relevant? Is it fresh? Is it familiar? Is it fair? Is it transparent? Does it account for diversity, inclusion, equity? They're a significant set of principles that recommenders really ought to think through. And as product leaders, I highly recommend when you are building a recommender for whichever applied space you're focused on, get to know your customers, get to know your products, but also take a stance on the principles you want to embed in your recommender. And I hope that gives you a good blueprint.
That's an amazing feedback. I want to share like an experience from the first startup I built. It was a dating website, and we basically got the recommendation engine wrong. So basically, we had a few girls having hundreds of guys wanting to talk to, and a few others would have no one. And that was kind of a typical case of having it wrong because we really couldn't understand what are the key metrics we were optimizing for. So that was 2010. Anyways, Vishal, I know you've worked on also other products that have a huge impact on the balance in the marketplace. search pricing. I think that's not a typical, I mean, it's not very common, but a very interesting use case. So if you could tell us a little bit more about how you design and what are the different steps to get these products to market? What are, what's the recipe as well to build and develop these products?
Sure, thanks for the question. I would say that, for marketplaces, I would say that marketplace, if you think about problems in marketplace spaces, the one word that comes to my mind, when I think about, places like Amazon is a marketplace, an online marketplace, Airbnb is a, online, offline marketplace, Lyft, Uber are your on-demand marketplaces, real-time marketplaces, Instacart, Shipt are near real-time marketplaces. The one word that comes to mind when you think about building systems is balance, right? There are multiple sides into the marketplace, and you want to make sure that when you are building systems, the systems are such that, of course, if you're trying to build a system to augment one side and increase one side, let's make it a little more concrete. Let's say there is a supply side of the marketplace, there is a demand side of the marketplace, and then there is an inventory side of the marketplace, right? So by inventory, I mean, what do I mean by this? So supply, for example, let's take a simple example. Let's take Shipt, right? As a three-sided marketplace. What we call a supply is the gig economy or the gig workers, which are actually going and doing the jobs for us, shopping for us. Then there is your demand side, which is, customers placing orders. So that is your demand side. And then there is your catalog, which is the actual retailers where the shopping is actually happening. When you think about building systems, you cannot build systems such that one of them goes completely out of whack and the others cannot catch up, right? Because then the marketplace is going to be in an imbalanced state. It just doesn't work like that. That is the challenge of building a marketplace. And Faye, you are at Amazon, so that is also the defensible moat, if you will, right? As a if you think about it as a business strategic principle, it's also the defensible moat of what a marketplace is. It's very difficult to build a marketplace and scale a marketplace, but it is even more difficult once the flywheel, at some point, what happens in a marketplace is, supply starts complementing demand and demand starts complementing supply. A lot of people, for example, just take a simple example, will come to Shipt and place their orders at Shipt. Why? Because they get the orders served, because there are enough people on this side, on the shopper side, which are actually serving the orders, right? So that kind of a flywheel, and there is enough catalog information where there are enough retailers, enough stores around them where, they can actually place orders, meaningfully. There's enough selection to actually place the orders. So when you are building systems, when you're thinking about building systems, there could be for different in different parts. There are systems which may just try to augment or build up one side versus the other. It is important to maintain that balance in the marketplace. You just cannot keep increasing your demand if you don't have a supply pool. You just cannot keep bringing more and more retailers online if nobody's actually going to shop at them, right? For example. So that is one. And I think more than anything else, there are systems which you can build for only one side of the marketplace in this example. But then there are systems which are necessary sort of at the actual balancing point of the marketplace. Systems like pricing, systems like clearing the market, right? Offering, like you take the orders which are in your marketplace and you offer them out to your shoppers. Systems like that, systems like forecasting and, what do you think where your marketplace is going, where your metrics are going, things like that. They need a different mentality. They need a different mindset when you're actually building those systems. They are more complicated to build. Marketplaces generally are more complicated to set up and, get the flywheel going. But once they are up there, it is equally hard to disrupt, which is, proof is in the pudding. Amazon is a, over $1 trillion company. And it has been, 25, 35 years in the making at this point. And that is the reason why, because complicated to build, but once you get it right and you get it going, it's very difficult for somebody to come and say tomorrow that I can build another Amazon, right? It's not a dating app. It's not a messenger app. It's very difficult to come and build an Amazon, for example.
Absolutely. Thank you for sharing your perspective, Vishal. I'd like to take one question that we have already, and that's for Faye. And the question, if I understand correctly, is about reinforcement learning versus supervised learning in recommendation systems. And that basically calls another question is, where do you start to build, and with what data you start? Obviously, recommendation engines have a lot of tweaking and fine tuning, but you need to start somewhere, right? So Faye, if you could tell us a little bit more about that.
Yeah, I'll try and keep it high level, because this could, it feels like a tree. It could go into many directions. The question is about specifically reinforcement learning and its relationship to recommendation system. I do believe from an architecture perspective, whether you're using, reinforcement learning or contextual bandit, or you go all the way to different other model architectures, the architecture of the model can only be decided on the basis of the data you have. And the reality with a recommender system is that if you're training your models on historical data, your recommendations are as good as what you have historically amassed. I'll give you an example that is essentially a big problem right now in the AI space, where some facial recognition software has a 97% accuracy recognizing a white male face versus only 70% accuracy recognizing a female black face. And that's not the fault of the architecture of the algorithm or how the model works, nor even the accuracy metric of the model. It's only the fault of the data. That's all the historical data that the model got trained on. And therefore, some significant questions for us in recommendation, like for us to be able to introduce diversity, equity, inclusion, a lot of these principles, we needed to really scrutinize the data we work with. And when it comes to video streaming, that data is actual movies, and how these movies are being produced, how the casts are being selected. So it's not something that you can just solve by going and getting the right data. There's an entire other industry that needs to really elevate its practices to a whole new level of principles for us to, from a downstream perspective, make the streaming consumption relevant for members. So I think that, I hope that gives you a little bit of framing. It's not just the architecture of the model, it's also the data. But it's eventually the productionalization pipeline, and being able to keep monitoring your models, preventing decay over time, and making sure that whatever data you trained that model on is still kind of valuable and valid, but ultimately embracing real-time data, because that's going to give you even a stronger signal. And we all know introducing real-time data with historical data in model training is an incredibly complex task, specifically when you have, a scalable marketplace or service, and you have global footprint and many devices. It just, the level of complexity is prohibitive. So I hope that gives you a little bit of a sense, but I don't think there is an exact answer to this particular question. Thank you.
Yeah, I'd like to hear your thought, Vishal, about the real-time recommendations versus historic data. I think that's a topic that's very interesting in the search pricing, right?
Yes, for sure. Yeah, I think Faye touched upon a very, very good point, which is merging real-time data with historical data in a model and making predictions with that model is an incredibly challenging task. I'll give you a simple example. Companies like Instacart, Shipt, and DoorDash, the way we price our orders, the way we pay our shoppers for shopping an order it's called a effort estimation based price. So there is a machine learning algorithm which is trying to estimate, given an order that is placed by a customer. Let's say the order has, I'll make it up, 1 carton of milk, 1 crate of eggs, one pack of cheese, some cheese, and so on. If you were going and shopping in a certain store, you're probably walking around the store, going to the store, picking it up, shopping around the store, checking it out. Then you're actually, driving to the customer, and finally you're making your delivery. the way the machine learning algorithms work is they will look at the actual data of shoppers doing these type of shops, and we will train the models, right? And we will, train and predict those on those models. Now, the problem with what Faye was mentioning, what you brought up, surge pricing is an example, but surge pricing is, the foundations of surge pricing. But I'm talking about the foundational problem, the context problem first. The problem with this is, if an accident happens, now here's two problems. Let's say if an accident happens on the street when the shopper is actually looking to shop, right? Like, they shopped and now they're driving and now they are about to deliver the package and an accident happened. What is the effort that shopper actually spent in delivering that order? Should we compensate them for all the time that they spent, just because it was not their fault, because they are trying, right? Or should we go on historical? Should we go on real-time data, which is what we should be compensating right now? Or should we go on historicals, which is, like last week, somebody else did a similar shop, an accident did not happen. It took them 30 minutes to do this. So we will pay them for 30 minutes, right? Now, here's the other problem. Let's say we decide that, okay, we will pay you on real-time data. It's not your fault, an accident happened. You were still on the job. We will pay you because you were on the job. Now, here's the other problem. I am a malicious shopper. I go to a store, I pick up an order, and I just sit there and I'm just reading books, right? Or I get in my car and I'm driving to my family, driving to see my friends, do like 20 things. And now I'm, how do I say, how do I prove to a shopper that, should I now start getting into mapping and auditing the route where we had originally suggested, should I build a whole mapping system where I'm like, oh, we told you to go along this route, but why did you take a detour? Right? Like, you are probably going away from that. Is that what the shift is really, do we need to build an entire mapping system to control this? So these type of questions, right? That is what makes it challenging to use real-time versus historical data. Even if you think of maps themselves, even Google Maps, right? The way the traffic predictions in Google Maps work, we know because we use them all the time, is they have something called a pessimistic, a best case, and an optimistic estimate. It is never really real-time estimate. It's never really like an accident happened and now it will take you, 3 hours to drive something that usually takes you 15 minutes because some accident happened on a bridge. They never really predict that. They never really do. When you call their forecasting APIs, they will tell you, okay, worst case scenario, looking at the recent history, right? Recent history, looking at that, it's so much time. Best case, it's so much. And an average case, looking at what we think is happening in the marketplace, it would be basically around this. So there's a pessimistic, optimistic scenario. How does this kind of relate to, something like surge pricing? So we talk about things like, one of my favorite topics, and I've spoken about this topic in other forums. One of the topics that I am intimately familiar and love talking about, personal to me, is surge pricing, is dynamic pricing. Essentially, dynamic pricing is a broader umbrella, right? Where you can just to paint context, right? You can think of dynamic pricing as a very sort of something that hits home. A very easy, casual example of dynamic pricing is your happy hour. You go to a bar, they have a happy hour between 6 to 7 p.m. What are they actually doing? They're really dynamic pricing, lowering the price in an offline scenario for customers to be able to come in to get more foot traffic, to actually increase their sales, right? That's what a happy hour is in the physical world. There are sales that happen, flash sales that happen, et cetera, et cetera. The word surge pricing, so there are various ways in which, holiday sales, Thanksgiving just happened, Black Friday, so on and so forth, right? All these there are pricing algorithms that are constantly looking at, if they price, this concept is called price elasticity. If I price, an item, whatever that unit that I'm trying to sell at a certain price point, what is my demand side willingness to buy, right? Like at what price point does my demand say, for example, if I price a sandwich at $10 versus $10,000, right? At some point, my customers are going to say $10,000 is probably way too off for a sandwich, right? I don't know in the world anywhere if it would be a $10,000 sandwich. So some point, maybe there is somebody who wants to pay that price, but maybe that's one person, right? So the demand actually gets much, 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 much smaller, right? In your classic economics 101, if you think about it. Same thing on the supply side. If you start getting the price to zero, the willingness to sell, right? Willingness to serve that order on the shoppers, for example, or people who are actually working for you, that gets lower and lower and lower when you increase price. So that's when I said originally, the beauty of working for a marketplace is maintaining that balance. Is as customers, we don't want to pay top dollar, but as shoppers, we always want to get top dollar. We always want to make the most money because this is a form of income for us. So it's always that, that balancing point. What point do you maximize the orders that are going through your system for both sides, right? You are maximizing the payout so that enough shoppers are in the system and actually serving your orders, but you are not charging so much that there is no demand at all. How do you find basically that balance point, right? If you think about it. And in surge pricing, coming back to what I was talking about, APIs, like, real-time APIs, surge pricing specifically. So there is dynamic pricing. Dynamic pricing is, everywhere. Happy hour is one example. You think about keywords, right? Google or Facebook ad keywords, when you're placing ads, those keywords, there is something called a minimum reserve price or a minimum price for advertisers to bid on those keywords. For example, I worked at Yahoo Search, a long time ago in the advertising department. And at the time, the cost of bidding, the minimum bid for putting an ad against the keyword insurance was actually $5 for every click that you get. Let that sit for a second. For every click that was generated on that, there is no conversion, there is nothing, there's nobody guaranteeing that there will be an insurance bought or sold. Anytime somebody clicks something on yahoo.com, searches for insurance and clicks an ad, the engine makes $5. And that price was not random. There were algorithms that came up with what is the floor price below which we will not sell this item, right? There is this item, there is this keyword. What is the price? So this type of pricing is everywhere. Surge pricing specifically is, as we understand in the, it's a new trendy word. It has come into picture really in the last 5 to 10 years with Ubers and Lyfts really, taking off. Surge pricing is basically pricing in real time using market dynamics. So this is where your real time meets your behavioral finance, meets your machine learning. What is somebody willing to pay, right? If I show that to female versus a male, who's more willing to pay, and then all of that together, that's where surge pricing actually lies.
Yeah, that actually brings us to the second section of the talk. Understanding all of these different things that happen, the marketplace dynamics, the consumer and their expectations, and then understand the underlying technology, the algorithms, but also the MLOps, the latency. Huge amount of skills to have to be able to build these products and launch them. These products are, one of the most complex products from every sense: technical, design, experience, huge complexity. Right. So basically, my question to you guys, both of you, whoever wants to answer this question, is, you told us about your recipe to build the products, but what's your recipe to build teams? How to build a strong team that captures all of that complexity, that has basically all the diversity and the various skill sets that are needed? Whoever wants to answer.
I'd love to answer that. And in fact, if we can share that slide number 6, just to give people a little bit of a visual as I give them some historical perspective. When you think back to the late 90s, early 2000, companies were embracing digital transformation. And every business had to build some form of digital presence, create a website, offer some services online. And I believe what happened as a result of that is we saw the birth of a product designer role. This is a hybrid of product manager and a designer coming together. And these are people who are very fluent in defining user experiences and very immersive interfaces. 20 years later, in fact, this started about 5 years ago specifically, we have started to see the birth of a product scientist. This is a product manager and a machine learning practitioner. And if you all are seeing that slide, I'm not sure if it's coming up here.
We're having a small issue with the slides, so I'll
No worries, no worries. But basically, to build a strong ML organization, and I've been really experimenting in this space for the last decade. What is really the right mix of skills, the right mix of design? I have to admit that there are at least 5 unique roles that product management in ML requires for the success of the team. First of all, a product scientist, meaning someone who can build models themselves. They actually understand the ML life cycle. They understand everything that happens from data management to model engineering to productionalization. It's really important for them to be able to have in-depth conversation with the scientists on the architecture of the models. Then there is another role, and by the way, these roles can live in one person or multiple people. So it's really, right now the industry is still, the talent is not there, and people are kind of growing in various directions to kind of get into this space. Data product manager is the second role. This is someone who is sole focus is to oversee the full life cycle of how data is used in an organization and how it really feeds into the product, and kind of builds some level of governance and workflow around data. A third really important and unique role for machine learning organizations from a product standpoint is an experimentation product manager. Experimentation product managers are people who needed to oversee the overall A/B testing platform, understand what experiments are going in, understand how basically you develop results and analysis and make decisions, modeling decisions based on those experiments, but also they have the pulse on which models need to be pulled back from production, go back into some other retraining, other re-experimentation before you refresh them and put them back in production. Those, I would say, if you can afford these 3 roles, those are really essential. There are 2 additional roles that are also really important, is product analytics, people who are expert at tracking, visualizing and analyzing data, user behavior, all the information that you get about your customers, having a pulse on metrics of success, and really examining the product analytics. I think this is a very important area because all of your decisions in modeling are going to be driven by the data that comes from this expert. Lastly, there's a product economist. These are people who truly define the economic models. They really think about pricing theory, behavioral causality. You really need them when you're building complex systems and you're trying to arbitrate across different marketplaces or content providers. Having economists is incredibly important. But it goes to say that we cannot ignore the fact that you really need traditional product managers who are not necessarily experts in ML, because I do believe traditional product managers bring a unique set of skills, the ability to actually get products to market, the ability to define products, to define vision, to be very customer centric. And it's important for these people, one of the best roles for them in a machine learning organization is to really define the principles of that organization. What are our practices in, basically principles in AI? What are our practices in fairness, transparency? What are we doing about inclusion? What are we doing about equity? All of these principles that are incredibly important in the age of the machines, because we don't want these, powerhouses of machines to end up kind of basically ruling our own experience. So you need really these checks and balances and people who define these principles and help implement these principles. I do have to say that organizational design varies across companies. Some companies have it centralized, some decentralized, some federated. And at different levels of maturity of the organization you're in, a different organizational model will maybe be better. But it's really important, regardless of how the organization is designed, that every single one of those roles have a direct pulse on the customer. Unlike traditional product management, where you can have voice of the customer isolated in one team, it does not work in machine learning. You have got to have every single product manager deeply connected into customers, understanding the customer needs, problems, and really bringing that in the thinking about metrics, about data, experiments, models, and the ultimate product. And I think in this graph, what I show is in blue is the traditional vision to value product management practice that plugs into product development, specifically at that stage between product requirement defined and now having a roadmap that needs to be ready. And model engineering, when it comes and plugs into that, it introduces three variables. It introduces models, data, and time. The time aspect is where we experience model decay. I will leave the next slide to another question, because the next slide zooms into the actual ML life cycle and explains that that is the next level of complexity that gets introduced for product managers. And that's why you need these very technical roles that are unique and try and understand various aspects of the life cycle. I hope that makes sense, and would love to take questions, obviously, in the chat.
Absolutely. Vishal, what do you think? What are the roles that are most important to different types of organizations?
Yeah, that's a great question, and I think this slide is a great guiding principle for us. I will say that I will echo what Faye said, but I will take it, take it in a slightly different angle, in the sense that so as members in the audience, right, as you're thinking about specializing, as you're thinking about where you want to go, what is your passion, what kind of a product manager do you really want to be, or even if you want to be a product manager, what is your path, what is your avenue to actually get into product management, right? Like, so Faye gave a very, very sort of detailed answer, and that answer would be very relevant for a company. For example, a big company like Amazon, Apple, Facebook, Google. There is a lot of capital, technology capital that is already built into these companies, and they are basically trying to really specialize because they need it. They have the scale, they have the revenue, they have the complexity, they have the number of transactions that are going on per second, right? They need these kind of specialists for being able to experiment, for being able to create economic models, for this and that. Like all the large scale companies, they actually have those kind of specialized roles. Let's take it down to a slightly smaller company, smaller organization, which is fast and nimble, not a 10-person company, not a fledgling startup, but something that is mid-size, right? Something that is between mid to something like, there's only so many Amazon, so many Facebooks, and so many Googles in the world, right? Something in between. So what do product managers there, what do we expect, or what can you expect as a PM? So this slide is a very nice guiding principle. It talks about, what does a PM exactly do? They research the problem, they find out who the problems, they go to customers and find out who the problems are for. They formulate the requirements, user design stories, user stories, they put it on paper. Then they create, this I think, agnostic of what type of a product manager you are, product roadmap and prioritization of what you're doing and why you're doing it is something that every product manager, or even every business leader needs to be really good at, and honest at, right? Like, is this the right problem that we want to focus on? Because especially as product managers, one thing to remember is that we are leaders of influence, and the decisions we make impact everybody, all the engineering, all the data scientists, all the designers, all the engineers, everybody around us. So it's very important to make sure that you have conviction, database conviction, not just you feel that you want to release this feature over the other, but you can back it by data. So that road mapping and prioritization, I would say, is super important. Obviously, launching products, getting things done, and finally measuring whether it works. But across these skills, right, if you think about this spectrum of skills, there are really three types of product managers that I envision. Three types of products that I envision. First, I would say, I would use a simple example, the example that I just used, which is price, price orders and price effort for serving orders. Let's just use that as an example. So there are three layers to that problem. First part is you have a machine learning model where you're trying to accurately estimate, what is the time that it takes to serve an order. Second part is then, that machine learning model is plugged into a system where it is actually calculating the pay. We basically pay on that time estimate. So is actually calculating the payouts of that, right? And the third one is that dollar value that is calculated is actually coming out shown in the app. So a product manager can be sort of in terms of like a company, in terms of the category of problems that you're solving, you can be in one of those three broad buckets. You can be a technical product manager, which is squarely focused on machine learning, analytics, so on and so forth. You can be a product manager, which is in the middle, which is taking that technology and moving that to production. Or you can be a product manager in the front, which is working on the app, working on things that are tactile, things that you can actually touch and feel and how that actually behaves. A product manager, which is on the back sides, for example, right, towards the machine learning models as well as the middle, those two sides, you need more analytical and data science related skills, is what Faye basically referred to. But when you come to the middle and the front side, at that point you need to be more visually driven, more visually passionate about visuals, things like how many people are coming back to you, right? So the metrics that you would look at, for example, for a PM, which is on all the way on the left side, is you would look at accuracy of the model. You would look at what was the predicted time what was the time predictions that we had versus the actual time that shoppers took to shop. How many times did we get it right? How many times did we get it wrong? Things like that would be, you would work, figure out, focus on that in the left side. On the very right side, you would actually focus on customer impact. How many shoppers are coming back to us because we are showing them this price? What is the retention of shoppers? How many orders are actually getting served out of the marketplace? So it just depends on what you want to do, what skills you have. I would say in mid-sized companies, again, as Faye did touch upon it. It is important to have a cross-cutting sort of skill set. A product manager is the way I define a product manager, they are very, very good generalists. They are rock star generalists, but they are superstar in something else, right? So, superstar data analyst, but a rock star generalist, right? Like that might be, or a superstar, designer, but a rock star generalist. So that's the best analogy that I would give. So find what your passion is, find what your skill is, figure out how you can leverage that to get into it. And then from there, you also need to be well-rounded in all these different aspects, which are right here. This whole spectrum, you have to be well-rounded in the spectrum. You may be a superstar in, road mapping or prioritization or picking personas. Your writing skills might be excellent. You might be able to translate what users want into user stories very, very well, better than anybody else, for example. Or you might be able to track and measure and come up with metrics like nobody else, for example, right? You're very analytical. So it just depends. So pick your area, but don't ignore anything else. All of these are kind of required when you want to become a mature product manager in your career.
Awesome. So I'd like to leave some time to answer the 2 or 3 questions that we have in the chat. But before that, I'd like to ask you kind of the question in the mind of everyone in the audience, at least the students in the audience. So how to get into this space? What you need to learn, and what are the tricks, the small hacks that helps you get in this space? How to become a machine learning PM? Both of you, Faye or Vishal, whoever wants to answer that.
Yeah, I think I'll kick it off. I think I'll just say what I basically said. Again, if we are specializing into it, I'll just keep it brief, and Faye, you can add more. But if you're specializing into becoming a machine learning PM, I think Faye laid out the field for us, right? She basically said, these are the skills that you really, really need to be good at. You need to be very good with numbers. You need to be very good at experimentation. You need to be very good at, figuring out, the impact of, okay, there is a abstract metric called accuracy, right? Accuracy of, root mean square error. There are all these, for people with stats background, there are all these different ways of measuring error, biases, right? Diversity and inclusion, but basically biases in a model. It predicts well for certain cases, but it completely underpredicts for certain other cases, and it's just very, very inaccurate for certain other cases, which is basically training bias or prediction or estimation bias, for example. So there are all these different use cases. For a machine learning PM, you need to be very, very good with numbers and abstract thinking, I would say, right? You need to be able to, put the picture in your head, see how that actually connects with what is an impact that it is actually going to have in your marketplace, in the problem that your top line problem that you're trying to solve. For a general PM, if you're interested in some other parts of the problem, then it's a different story. Yeah. I would love, Faye, you can take it from here. You obviously.
Yeah, of course. I think product management is a very interesting field. It doesn't come from a specific degree. I mean, an engineer gets like an engineering degree, a designer gets a design degree. Product managers come from engineering, from design, from business, from a lot of other disciplines. So the one thing to leave you with is it's a field that cares about diversity of background, but ultimately a product manager is the CEO of the product. And the future, the next 20 years are all about AI. So if you're really deeply passionate about product management, about being the CEO of these ideas that you're building and making and services that you're bringing to the marketplace, then by all means, get into the AI space and get into it in a creative way. Take classes, get into it from a data science perspective, maybe from learning how to model, or maybe by speaking a lot with data scientists or with applied scientists and understanding how they think, or maybe get into it from the economic side. I think the next 20 years for your job and your aspirations to remain relevant in product management, AI is a must. Just learning and soaking it in is really the ticket to it. I don't think there's any other recipe. It's as simple as that. So.
Well, that's great feedback. We still have 5 minutes. We've got some questions. Maybe Mohamed Azhar can help us kind of review the questions. Would you like to summarize the questions?
Yes, Bilal, thank you. So there's one question here from Matt. He asks, what's the North Star for, and the question is for both Faye and Vishal. He asks, what's the North Star for your products, and how did you define, how do you decide on the core metric? Now, for example, Facebook focuses on engagement as a proxy for the user finding value. So is it similar for you to do for you, or do you use a different methodology?
Sure. I can start there. I love talking about metrics. I'm, a numbers guy, and this is again a question that is close to my heart. I would basically say, I would start at a high level, and I would say that there are generally two types of problem spaces, at least in my understanding. There are two classes of problems where companies exist. There is one class of problems which is an eyeballs business, which is your Facebooks, your Snapchats, your Google Newses, your New York Times, and all of that. It's an eyeballs business which is monetized in a different way. All your games, for example, right? Eyeballs business, which is a lot of users, and engagement and retention are those sort of consumer facing metrics. And then there is another class of problems which is transactional business, which is you are in the middle, you're in the business of taking a margin, the Amazons, the Lyfts, the Ubers, the Shifts, the Instacarts. That is a transactional marketplace business, right? Your TaskRabbits, your anything else that enables work. It depends on, at a high level, when you're looking at these two businesses, at a high level, the metric for an eyeballs business is bring demand. So have users aggregate all the demand, they are demand aggregators, aggregate all the demand, retain the demand, engagement and retention, and then we'll figure out when demand is there, supply will follow. So then the supply for them is basically advertisers, other influencers, other people producing content, and user generated content and all of that. That will follow. But keep your North Star on demand, on engagement, and basically that is the company's North Star. How many users? On the other hand, for transactional businesses, including your Targets, your Walmarts, and all of that, it is basically the number of orders or your profit, because it is a margin business. Right, so it's your total number of orders and the margin that you're collecting per transaction, revenue per transaction, if you will. So it depends. But that said, these two are sort of like your high-level business goals. Now, what happens is when you are building products, right? Let's say, we built a surge pricing engine, for example, right? Like what is good for a surge pricing engine? Let's talk about surge pricing for just 1 second. What is good for surge pricing? If you increase the prices, is that good? Because, now your demand is falling. If you decrease the prices, is that good? Because now your supply is falling, because now your drivers are actually leaving the marketplace. So balance. But how do you measure balance? The way you, for a surge pricing system, for example, the way you measure balance is how many requests have, let's take Lyft or Uber as an example. How many requests have a very, very high ETA? So service quality. So although the word pricing, right, it has the word pricing directly into the system, price is not an outcome of that system. It's not a North Star for that system. The North Star for that system is service quality, which is how fast are you clearing your marketplace. So again, in a transactional place, that then ties to how many transactions are happening, and that then ties to how much our GMV and our margins are inflecting. Different for Facebook's and Google's. Yeah.
Thank you. Faye, would you like to add either a remark on this or on the question about how to become a PM?
I guess I'll annex this one a little bit, and then we'll take that one, and I'll keep it very succinct. We're at time, actually. I think to Vishal's point, whether it's a transactional business or a consumer business, every business is in search for customers. Every business North Star is to get clients, right, at the end of the day. For recommendation, I actually beg to differ on that, in the sense that it's not just about getting the clients, it's about delighting the clients. It's about getting the right products, the right recommendation, the right offers to delight the clients. So in the space of recommendation, I do see the North Star more customer-centric than not. Having said that, you cannot just be customer-centric. You have to also integrate the business value and how you can drive revenue. And it becomes an interesting economic equation of how the North Star metric needs to bring those two together. And balance those multiple objectives. And in fact, in ML, there is technology now that helps optimize multi-metric North Star, basically, models, which is great news for companies that needed to think about different objectives and how to kind of optimize them on behalf of the customer. In terms of, I think the other question you said, I think we answered how to become a PM. I think there was a question about product and engineering, how to create alignment. I think very briefly, this works with product engineering, but also in life in general. I think shared purpose is really what brings people together. And as much as engineering focuses on solving for tech debt, product managers need to focus on solving for vision debt. Yep. And I strongly believe that it's in the product manager wheelhouse to really create a vision, inspire a sense of direction, and really bring the teams together. The second piece to create alignment is communication. That's, sky's blue. It's always important to communicate and find a way to communicate with various team members. So some people are more email driven, some people are doc driven, some people are Slack driven. We are definitely continuing to evolve in our communication styles. And then lastly, trust. And trust is built one day at a time. It's never guaranteed, but it does take a lot of humility and vulnerability and leaning into building that partnership and creating a relationship capital. I think those three are really essential for a product manager to be successful with all their partners, not just with engineering. And with that, I think that wraps it up, unless we have another question.
Yeah, we do have a question, but unfortunately, Chanye, we would not be able to answer your question. Time is running out. I'd love to have a little bit more time. I want to thank everyone for participating. Faye and Vishal, you've been extremely generous with your time and with your knowledge, and I'd like to extend my thanks to you. Also, I would like also to thank everyone who basically participated in preparing and organizing this, the staff of CMU, the PM Club at CMUSV, the PM Club at Pittsburgh, and also the CMU Tech and Entrepreneurship community. So thank you, everyone. Thanks for the audience, and would like to see you soon. Thank you.
Thank you, guys. Thanks for your time. Bye-bye.